Have you ever wondered why AI suddenly became so much powerful after 2022? Before that, most AI systems were built for specific tasks. And if you wanted AI to solve a completely new problem, you often had to build, train, or fine tune another model specifically for that task. But today, a single AI model can write code, answer questions, summarize documents, analyze images, create content, and perform many different tasks, all within the same system. So, what made it possible? The answer is foundation model. Hey everyone, I am Sumita, and in this video we are going to understand one of the most important concepts behind modern AI, that is foundation models. If you are learning AI, machine learning or deep learning, you have probably heard this term. And if you are planning to build a career in generative AI or large language models, understanding foundation models is absolutely essential. So, in the next 5 minutes, let's quickly understand everything about foundational models. Let's get started. So, what exactly is foundation model? In simple terms, a foundation model is a large AI model trained on broad and massive amount of data to learn general patterns and capabilities, which can later be adapted to many different tasks. Now let us understand foundation models with simple example. Let us think about constructing a building. Before we build different floors or room, we first need a strong foundation. You know why? Because we don't want to create a completely new foundation every time when we want to add something to the building. At first, we will create a strong foundation and then we will build different things on top of it. So, foundation models also work in a similar way. At first, the model learns patterns and capabilities from the massive amount of data, and then that learned capabilities becomes the foundation. Later, the same models can be adapted or used for different applications like answering questions, generating code, summarizing documents, or analyzing images. So, the basic idea is one powerful foundation for many different applications. Interestingly, the term foundation models was popularized by researchers at Stanford in 2021. Now, if you carefully read the definition of foundation models, then you will notice three important components, that is architecture, data, and training. Let's start with architecture. Foundation models can contain millions, billions, or even trillions of parameters. Parameters are essentially the values the model learns during training. You can think of them as the internal settings the model adjusts to learn patterns from data. One of the most important architecture behind modern foundation models is transformer. Transformer becomes extremely important because they are very effective at learning relationship between different part of inputs using a mechanism called self-attention. For example, when processing a sentence, a transformer can learn relationship between words even when those words are far apart. There are also other architectures like GANs, autoencoder, which are also used to build foundation models. So now next important components is data. The amount and diversity of data can be enormous. Depending on the model, this data can include books, articles, websites, code, images, audio, video, and many other sources. The goal is not simply to memorize this data. The model needs to learn the underlying patterns within it. And finally, we have training. During training, the model repeatedly makes predictions, receives a training signal, and adjusts its parameter to improve the model. This happens again and again across massive amounts of data. For many foundation models, this large-scale initial training is called pre-training. A major technique used here is self-supervised learning. For example, a language model can be trained by predicting missing or upcoming pieces of text. By doing this over billions of examples, the model gradually learns grammars, concepts, relationships, patterns, and many other useful capabilities. Now that we have understood three components of foundation models, let's quickly see why are foundation models so powerful. Traditionally, If you wanted to build an AI system for a particular task, you often needed task-specific data and a model designed specifically for that task. For example, like for sentiment analysis, one model was needed, image classification another, speech recognition needed another, and so on. Foundation model changed this approach. Instead of starting from zero every time, you can start with an already trained foundation models and adapt it to your specific requirements. This can happen through techniques such as prompting, fine-tuning, or connecting the model to external data and tools. For example, suppose you want to build a customer support chatbot. Instead of training a massive language model from scratch, you can start with an existing foundation models and adapt it to your company information, instruction, and requirements. This dramatically reduces the amount of work needed to build many AI applications. And that is a major shift foundation models brought to AI. Now let's move to the next question. That is, where do we actually see foundation models being used? Probably more places than you realize. Language models like GPT, Gemini, Claude, and Llama power assistants and writing tools. Image models like DALL can generate pictures from text. Speech models like Whisper transcribe audio, and other multimodals now can handle text, images, audio, and video together. We can even adopt foundation models for specialized fields like medicine, finance, science, and many more. So, foundation models aren't limited to just ChatGPT or LLM. The underlying idea can apply across different types of data and different areas of AI. Of course, foundation models are not perfect always. One of the biggest challenges is hallucination. Hallucination happens when AI models generate information that sound confident and convincing but is actually false or misleading. They can also reflect and amplify biases present in their training data and raise real questions about privacy, copyright, security, and the responsible use of data. On top of that, training these massive models takes enormous computing power and energy. So, foundation models are powerful, but they are not magic. They still need high quality data, careful evaluation, safety measure, and human oversight. Now we are at the end of this video, so let's quickly recap. A foundation model is a powerful model trained on massive data and adapted into countless applications, from assistant to image generation to specialized tools in medicine and finance. That is the shift foundation models brought to AI, and it is why AI feels so much powerful and capable today. If this video helped you understand foundation models, hit like, subscribe, and share it with someone learning AI. Thanks for watching. See you in the next video. Bye bye.